I will do the attendance first, yes. Okay, so back home, Gian, are you here? Yeah. Okay. Charles, about here. Okay. Cedric, here. Kyle, Sean, okay. Amrinder, Harmandeep, Manveer, Manveer, Namanya, Jason Cabilo, Gavin, Gavin, are you there? Anthony Campbell. Here. Okay. Ona, are you home? Yeah, okay. Uh, Lance, are you here? Are you online? Kamalpreet, are you online? Okay. Pearl Yagas, Maxwell Macaluso, Keisha Mangoon, Jadelyn. Oh, you're here? Okay. Jadelyn, Mark Mariano, okay. Cassie Mendoza, Laura Polaris, Danielle Sutherland. Okay. All right. So we talked about the descriptive. We started talking about the descriptive form of the um, quadratic equation, like of a parabola, right? And so it normally looks like this, right? So where h and k would be your the coordinates of your vertex, okay? So a still does the same thing as before, except for when it's in this form, when you have the bracket squared, then you know that you can get your vertex from it, not the y-intercept, okay? It's not the standard form. So if you wanted y pointing down and one x-intercept, if we wanted y and down, we would just go negative 0.5, right? And we could go minus 5 squared, where we're going to make this plus 0, right? Because if your y value of the vertex is right on the x-axis, then you are guaranteed to have an x-intercept, just one x-intercept, right? It doesn't matter what this value in here is. So if I ask you to come up with an equation, you still should have something there, right? So we will just turn that into this, right? This is really what you should be writing down. I just do this to make that clear that if k is equal to 0, right, you're going to have, it's going to be like this, right? Regardless of where that the x value is of the vertex is going to be on there somewhere, right? So you fulfill that requirement, all three requirements, right? calculate the y-intercepts algebraically. Okay, so if you can write this down like that. Algebraically is manually, right, by hand. So maybe if you need a reminder, it's just a fancy way of saying by hand, like you have to show me the steps. And this takes you back to IAPR, right? You would have done it this way. Okay, so Pearl, you're here. Okay, so the y-intercept is when x is equal to 0, right? So I will do a right here, right next to it, and use up the space here. So essentially, x is equal to 0 when you're looking for the y-intercept. So you go -3, 0 minus 5 squared plus 5.25. Okay, so you've essentially just substituted 0 instead of x, right? Let me just focus. There it is. So that would mean that the next line, so you can just omit writing this for now, just focus on the right-hand side. That'd be -3, -5 squared plus 5.25. So just cleaning it up one line at a time. A number that has an even power will always be positive, right? And or to summarize it, if you square a negative, you will always get a positive, right? So that'd be -3 times 25, because it's 5 times 5, it's not 2 times 5, okay? That's 5.25. 3 times -3 times 25 would be -75 plus 5.25. And then that would give you -69.75. So f of 0 is that. So the y-intercept is 0, 69.75 negative. Now, there's a way to confirm this, right? To make sure you got it right. Okay, that's where your handy dandy calculator comes in, right? So I will just show you how this is done. If you want to follow, you can do that. Plot 1 is turned off because I'm manually entering it, but you go -3, right? And then it's x minus 5 squared plus 5.25. Try to graph that, and there it is. Okay, if you want the y-intercept, you got to just change your window a little bit. Right there you see it crossing the y-axis, and then it's second trace 1, right? X is equal to 0, and you get that confirmation there, right? That you've done it right. But when I say by hand or algebraically, you have to show these steps, okay? Could you have skipped? Could you have gone from here to here? Yes, I would have been okay with you skipping like one line maybe. But show how you substitute, then show one line where you have them to separate it, and then you add them up, right? So just be careful with your signs there. And so B I will do over here. H of 0, -1/2, 0 plus 1.75 squared. Don't forget the squared, that's a common mistake. Okay, so basically you substitute in zeros for x, and you can turn that into a 0.5, right? And I will already square the 1.75, okay? That's 3.0625 minus 12.54. You multiply this by negative 0.5, you get negative 1.53125. Do not round. Right? A negative times a positive will give you a negative. And this is also a negative, so you're adding negatives, right? So your final number should be negative 14.07. That's when you can round at the end, okay? So h of 0 is that. So the y-intercept is 0, negative 14.07. So it's really just applying basic arithmetic, right? Like square this, right? Bed mass, really, it's bed mass all over again. And so you should be able to do this by hand. So, by the way, you have found a point on the line, on the curve, right? When you do this, yes, we call it specifically the y-intercept, but you found a point on the curve. Same here, you found a point on the curve. Okay, so now I'm asking you to find f of negative 4 and h of negative 3. Go ahead and try to do that right now on your own. So f of negative 4, that means that you have to use this equation, plug in negative 4, right? H of negative 3, you're using this equation, but you're plugging in negative 3. I'm curious to see what you would be getting there. So go ahead and try that right now, because after that I'm moving on, okay? there are your answers. So the idea, it's very important to realize that when you're finding f of -4, you're finding the y value when x is equal to -4. That's really what you're doing. So that's why next to it, I always write it down like this, right? When x is equal to -4, right? This is a point on curve. Point on curve. And it's kind of like the x variable, you know, when we do the types, right? You assign a value for width, and then you find the length, or vice versa. That's what you're doing. Like, this is your independent, right? And you're finding the other one based on the input. So everything we're doing here, we're actually finding a point on the curve. Okay, sometimes specifically the y-intercept, sometimes it's just a random point, right? So you need to know how to do that. So jot down the answers if you haven't copied it, if you want to do it on your own. I strongly encourage you that if you didn't get this, at least have the answers down and then try it again, practice on your own, see if you can get there. And notice that I showed fewer steps here, right? I find that this negative, you square it, and then I already multiply it by -1/2, so to give me this. So that's okay to do, but you can't just have like go from here to your final answer, right? That's not going to be enough for a question like this. Okay. We good? All right. Not yet? Okay. What I will do is we'll do a little chart here, which I have further up. We're going to do a bit of an exercise to see how you would be able to do this at this point. We good? I can come back to it if I need you to copy this chart. Okay, it's very important. So I'm going to zoom in a bit more. So, I don't know, half a page, a third of a page. So you need 5 columns, right? I need 2, 4, 6, 8 rows at least. Okay. And I'll tell you this, the one we just did where I ask you to do things algebraically, that's about as much algebra as you're required to do. Everything else you can use your calculator to do that. Even if on the homework it says do not, like without the use of a calculator, determine this or that. You use your calculator for that. There are certain things, for example, I would like you to know what A does, right? What does A do? Or what does B or C, what would they change on your parabola? That you're supposed to know, right? So as soon as you're done copying this, remember that there is no word problem associated with any of these equations. So then the domain and range goes back to how we started, okay? So I would like you to fill in the information that I'm asking you for. Maybe I should say when it's min and max, it's the equation of min and max. Axis of symmetry is also the equation, okay? So it's implied. So it should be y equals for min and max, and it should be x is equal to for axis of symmetry. So take a few minutes to answer this, and then we will move on with the quadratic formula, which is what's coming next. And I remember telling you that it doesn't matter how scary the equation looks, you plug it in, okay? Exactly the way it is. And as you're writing this down, okay, I will clarify. An email came out today saying the division is saying that there will be no exam week. Okay? No, that's exactly what I'm clarifying. That'd be sweet, wouldn't it? There will not be a scheduled exam week, which is usually 7 to 8 days of school time that's cut. So we instead you will have like your in-class exam, right? You're going to basically teach right until you write your in-class test. I'll call it like a big test at the end, or you can call it an exam or whatever. But the details are being flushed out, but it's not going to be in the gym, hundreds of students writing 11 applied, right, or whatever. It's not going to be like that. That's all that it's saying. So don't think that there's not going to be an exam. That's not what was said in that email, okay? So sometimes it comes out and comes out wrong. I'm going to clarify that as we get closer, okay? So right now we'll just focus on one unit at a time.
The deals for the type of questions, they're not working.
Type 1. Oh, okay. Okay. I think what happened is that I took them down for a bit. Let me see. Yeah. Yeah. It should be available soon. You can do both, Mark. You can do -1/2, or you can just put in -0.5. Just be careful if it's a fraction that isn't finite, then put it in as a fraction, don't round it as a decimal. Okay, so if they're descriptive form, then that's what you do. So here, this is technically a +0, right? Like k is kind of hidden, right? So my vertex is 7 positive, right? And the 0 comes from here. But you could also use your calculator to do that, right? So if you go second trace 3 for minimum, oh, so there it is. So left boundary, right boundary, and so your minimum is 7. And remember, this is 0. Whenever you have the e -15, it's really 0. So that's where that comes from, either using a calculator or just using the equation from it. And then these two, you simply take your vertex to answer that. The x-intercepts, you just make y2 equal to 0, right? I added that here on my keystrokes, and then you find the x-intercepts for all of them, except for this one. There's an issue with it cannot detect the change of the sign. I don't know what it is that is making it do that. So I will just guarantee you that that's not going to happen on a test, okay? But it is actually 7-0, and you can kind of tell, right, that it's touching right there. If anywhere, it's touching right there, which is 7-0, right? So don't worry about that too much. The domain for all of them is -infinity to +infinity, or x belongs to all the real numbers. And then if it points down, it's less than. If it points up, it's greater than. Okay, that's the key here to remember. And I always use the y value of the vertex to answer the other side. And squiggly brackets, okay? And the y-intercept, I just use second trace 1, x is equal to 0. And that's how I come up with these numbers. Okay. And you have to make sure your window is set up accordingly, okay? All right. Now, we're gonna talk about another, I wanted to introduce solving quadratic equations, okay? So maybe start a new page if you can, right? So solving quadratic equations. And then I'm going to say when you are asked the x-intercept or intercepts. So when they're asked you to, when they say, hey, solve this quadratic, what they're really asking is determine or find the x-intercept or the x-intercepts, depending on the situation, right? So you've done that already, but sometimes the question will just say, solve this quadratic. If you don't know what they're asking you for, you don't even know where to begin, right? Okay. So note, x-intercepts would be the same thing as roots. Sometimes they call it find the roots. Is the same thing as zeros. Okay? They all mean the same thing. All refer to the same thing. Okay, so don't let that throw you off. X-intercepts is the same thing as saying roots. Okay. There are two methods of solving a quadratic. And they are number one, the quadratic formula. We will also know it as the QF moving forward. Number two, by graphing. Two options here. So today we're going to start talking about the quadratic formula, and tomorrow we'll start talking about how to solve by graphing. Okay, so two methods, quadratic formula and graphing. So first, the quadratic formula, right? So this one you're gonna have to have on your study sheet if you wanna be able to answer this one. And this is how it goes. X are basically the x-intercepts, right? Hold on. First of all, given y is equal to ax squared plus bx plus c. That is what I'm going by, okay? The standard form. If you would like to find the x-intercepts using the quadratic formula, right? Of course, you could do it using a calculator, right? But this is how you do it with a formula. Okay, so you take negative b, right? And I will put brackets around it because the negative is already there. Whatever b is, that's what we're going to plug in here. Okay, plus or minus. I will explain the plus or minus later on. Just write it down right now, and then later we will explain. Plus or minus square root of, and it's going to be a longer one, b squared minus 4 times a times c, like that. And notice that the square root is taking everything under its wing, not just the b squared, it's everything here. over 2 times a. This section right here is called the discriminant. So b squared minus 4ac is called the discriminant. It's a little aside here. If b squared minus 4ac, so whatever is inside, we call it the discriminant, right, is negative, right? That means no x-intercepts. If it's positive, 2 x-intercepts. If it's 0, 1 x-intercept. So the quadratic formula, this, I'm going to box that in. That should be on your study sheet. Right? Make sure you add that. I would probably add this too, because if you ever get a negative inside the square root, we all know we cannot take square root of a negative number. Then you will have to say cannot, oh, there are no x-intercepts. That is for sure. You can't just let it sit there. You're gonna have to answer this. The other ones, we're gonna actually come up with a numeric value for it. So we're gonna do examples. Let me do an easier one. 3x, hold on. Yeah, 3x squared plus 3x minus 3 is equal to 0. It is a quadratic equation, and it happens to be that it's equal to 0, okay? Think about it this way. When y is equal to 0, right, what is x? That's what you're trying to find, which is essentially the x-intercept, okay? So what you do when you have one like this, and I'm asking you to use the quadratic formula, you look at it, and it's in standard form, so you know that a is equal to 3, b is equal to positive 3 as well, and c is equal to negative 3. Okay, let me just zoom in here, or focus at least. Right, so this is the quadratic equation you're given. I'm asking you to use the quadratic formula to solve or to find the roots or x-intercepts or zeros. The first step you should take is extract a, b, and c out of your equation. Okay? Then the next one is to use the formula I gave you up there. So x is equal to negative b plus or minus? I will explain that in a bit. Just follow me right now. 3 squared, because b is 3, right? Minus 4 times a times c all over 2 times a. Then you clean it up a bit. Negative 3 is just negative 3, right? Like there's nothing to worry about there. Plus or minus square root of. You can actually type this in one shot using your calculator. Watch here. Right? You go 3 squared minus 4 times 3 times negative 3. Make sure you use the negative, not the minus. So that's the discriminant right now that you're computing. You hit enter, you get 45. Okay? So that's 45 inside the square root over, oh, sorry guys, this shouldn't have been 2a. This should have been 2 times 3 here. Can we change that here? Change that to 3 here. I'm hovering over it. It's not 2a. That's the formula, but a happens to be 3. So that'd be 6 here. Okay. I will continue this here, and I do this quite often, right? I will show you this. First of all, the discriminant is positive. So you will have two x-intercepts. The first x-intercept is found by going negative 3 plus square root of 45 divided by 6. The second x-intercept, so I just call it x sub 2, would be negative 3, and instead of plus, you will go minus square root of 45. That's how you get the second root. And you will be able to verify this later using your calculator, graphing this thing, right? So watch what you have to be careful with here. If you type this in, you have to be very careful. So negative 3 plus square root, you probably forgot how to do square root. You got to go second x2 to access the square root button, 45. And watch what I would do here if I were you right now. I would hit enter, and then I would divide by 6, which is this. Otherwise, it might give you an issue with bed mass. So that is your first x-intercept. So it's really 0.620 is your first x-intercept. And watch what I'm going to do. This is a very helpful tool. I just go up, copy the one I just entered, change the plus into a minus, hit enter, divide by 6, and it is negative 1.62. So it's negative 1.620. Okay. So there are your two x-intercepts. And I'm running out of time, so hold on. So here, homework. Okay. Practice this. Page 427. And I'm going to give you easy ones this time. 1 and 2. 1 and 2. That's it. Always use a quadratic formula. You can double check using your calculator later by graphing that, but always use the quadratic formula no matter what the question says, okay? All right, have a good day. And if you're online, you can log off. What's that?